So in the previous video, we were looking at simplifying single terms, right? We were only multiplying and dividing. But now we're going to take it a step further and add in some addition and subtraction, which means that essentially we'll have to factorize to simplify. Okay, so once again, let's look at some examples. I really believe that examples or learning through examples is key. So we're definitely going to be doing a lot of those. Okay, so let's just consider something quite not too hard. Okay, so 1.1 we have 2 to the power 4n minus 4 to the power 2n plus 2. Okay, so one thing I want you to get out of your head now. First of all, notice we have a minus sign here. Okay, these are two separate terms. 2 to the power 4n is one term. 4 to the power 2n plus 2 is another term. You cannot go and apply your exponent laws over here. You can't say this is a 2 and this is a 4 right now, okay? But say this was a 2 instead of a 4. You can't go and add up or subtract these exponents because we have a minus sign over here. Only when you're multiplying or dividing. Remember that, okay? So if we can't do that, then how can we simplify, or, how can we simplify this? Yeah, so we're going to have to go and factorize, okay? So we're going to have to take out a common factor. But looking at these two terms, there isn't really a common factor at the moment. The smallest thing we have is over here. We have a 2 to the power 4n. So looking at the 4 to the 2n plus 2, can we kind of like change this or break this down into a simpler form? Yes, we can. So it's kind of got the same idea as what we were doing before with single terms, where we try to break it down to a simpler base. So in this case, we're doing the same, but only so that we can factorize. So 4 to the power 2n plus 2, we can break 4 down to 2 to the power 2. And then everything is then raised to 2n plus 2. So cool. And now we can just simplify that quickly. So we have 2 to the 4n minus 2. So we'll just multiply the 2 with the 2n plus 2. So we'll get 2 to the power 4n plus 4. Okay, great. So what do you see now? You can see that technically we do have a common factor. We have 2 to the power 4n minus 2 to the power 4n plus 4. So 2 to the power 4n is our common factor. But looking over here on the right side, we have 2 to the power 4n plus 4. So we want to get rid of that plus 4. So we can actually write this as follows. So 2 to the power 4n. So we can separate this out. We can say 2 to the 4n multiplied by 2 to the power 4. And if you think about it, if you work this in reverse, you have 2 to the 4n times 2 to the 4. Since you have a common base, you just add the exponents. So it will then go back to 2 to the power 4n plus 4. So this is a very clever way of separating these so that you can factorize out this common factor of 2 to the 4n. And that's what we're going to do over here. Cool, so we have our common factor. Let's take it out. So we can say this is equal to 2 to the 4n multiplied by, and then we have 1 minus 2 to the power 4. Awesome. And then inside the brackets, we can simplify that. And it'll just simplify to minus 15. Awesome. And so if you were to simplify this, you just say this is equal to minus 15 times 2 to the power 4n. I don't even know why I'm adding the brackets. You could just say minus 15 times 2 to the 4n. But yeah, so can you see how... So we started off and we saw that we had a negative. Okay, we had a minus over here. So we knew that we couldn't use our exponent laws. And this indicates that we have to factorize. But we saw that we first had to go and break down this part over here so that we were able to take out a common factor. Okay. So it's very important to distinguish between when you have to factorize and when you can use your exponent laws. Okay, so on to the next example. Now the next question the type of question is actually very popular to be asked in tests and exams. So let's see, we have 1.2. So this is, we have 9 to the power half x, okay, half x minus 3 to the power x minus 1 over 3 to the power x plus 2. Okay, so what we've added now is just we're working with a fraction, okay. But what do you notice? You notice that we have a minus over here, so we know that we can't use our exponent laws off the bat, okay. So this hints to us that somewhere we're going to have to go and factorize something out. So at the bottom, you'll see we have a single term. We have 3 to the x plus 2. We can't really do anything with that right now. Also, if you look at its base, it's 3, you can't really break that up further. So we'll leave the bottom as it is for now. But if we look at the top, we have two terms. We have this term here and this term here, separated by the minus. So we are probably going to have to factor something out at the top in order to simplify this fraction. So at the moment, we don't have any common factors. The smallest thing we have here is a 3, but as a base. But what do we know about 9? We can obviously break that down to something smaller, right? So we can rewrite this. So let's just keep whatever's at the bottom. We have 3x plus 2. So we can rewrite 9 to the half x as 3 to the power 2. Let's just see, 3 to the power 2. And then we keep the half x there, minus 3 to the power x minus 1. Okay, and then we can just obviously simplify that. So this is equal to, let's see, so we have 3 to the power 2 times a half x. So that will just simplify to 3 to the power, because 2 times a half is just 1. So we'll just have 3 to the power x minus 3 to the power x minus 1. And at the bottom, we still have 3 to the power x plus 2. And now what do you see at the top? You see that we have a common factor of 3 to the power x, right? But in order to factorize that out, we're going to have to separate, let's just see here, we're going to have to separate this minus 1 over here because we only want 3 to the power x. So we can do that easily. So we have 3 to the power x minus 3 to the power x multiplied by 3 to the minus 1. Cool. And obviously all of this over 3 to the power x plus 2. So now we can factor out. So we'll say this is equal to, so we have 3 to the power x, factor that out, we have 1 minus 3 to the power minus 1. And that to the, that over 3 to the power x plus 2. Awesome. And then we can go and simplify this. So we know that, let me just grab a different color here. So we know that this guy over here, we can technically write this as a third, right? Because we can take the minus 1, the 3 to the minus 1 to the bottom of the fraction, because we don't like working with negative exponents. Okay. Another thing I want you to notice is at the bottom. So here we have 3 to the power x plus 2, right? Technically, we can rewrite that as 3 to the power x times 3 to the power 2. And what do you see here? You'll see that technically we have something that can cancel out, right? So that's one very common thing of factorizing when you have a fraction, is that something at the top might just cancel out with something at the bottom, which is very useful. Okay. So if I can just quickly rewrite this maybe in a different form. So let me just see here. So this will be equal to, so at the top we had 3 to the power x, right? And inside we had 1 minus a third, okay? And now at the bottom we had 3 to the power x plus 2. So let's separate that out. We can say 3 to the power x times 3 to the power 2. And now you see that the 3 to the power x cancels out at the top and the bottom, which makes things a lot simpler. Okay, that's the point of this, is to simplify this fraction. And so we are basically left with, so you have 1 minus a third at the top. So that will come down to 2/3 over 3 to the power 2, and 3 to the power 2 is just 9. And so we'll just tip in times, and this will be 2 over 3 multiplied by 1 over 9, right? Okay, and this will just simplify to 2 over 27, and that is the answer. So quick scope for this type of question. As you can see, we are working with fractions, and we had a minus sign. So we knew that we had to factorize. And once you do factorize, it's very common to have something at the top and the bottom cancel out, which will simplify this fraction